Hi, and welcome to my channel, JaberTime, where I do math videos for all levels, from algebra to calculus and differential equations, simplified with examples. I'm also adding videos on apps and programs to help students and teachers alike, enhancing the learning and teaching online. If you're new here, welcome, and consider subscribing and hit that like button so that I know that you enjoyed this video. And also let me know in the comments below if you have any questions. I do upload a video or two every week, and I'm so excited about converting all my math notes from teaching over 25 years into simplified YouTube videos with examples. Once again, thank you for being here and hope to see you again and again. Alright, let's get into it. This is part 4 in my videos about limits. We know the main formula, limit f of x as x approaches a equals L, and the precise definition of limits. It says if for any number, a small number, epsilon greater than 0, there is a corresponding number delta greater than 0, such that f of x minus L absolute value, I'm just reading it, I'm not explaining it, as you can see, less than epsilon whenever absolute value of x minus a, of course, has to be greater than 0, and we want it to be less than that number delta that was mentioned. Before I start and move on, I just want to let you know that this topic right here, precise definition of limits with examples, needs practice and practice and practice. It's a little bit tough to cover it in one video. So not to make it a 45 minutes video or an hour video, I'm just covering the basic concept clearly with a graph, and I'm taking my time with one example, so I won't confuse you. If you master this example and any similar examples like these ones, you will be able to understand different problems, because there's more than what you could see in this video. There's a way more. There's different levels of problems that you could handle or face. So maybe in the future, as needed, if I see that demand in the comments, I'll make more videos with more examples. I will. So I'll always pay attention to the comments. If you have any comments, just leave it for me below, and I'll take care of it. Trust me. I mentioned that before, and I'll keep saying it. I'm committed for these videos, and I'll just keep going. Alright, now, what is the precise definition of limits? Well, I mentioned it early, typed. Now let's move on. Assume that f of x is defined for all x in some open interval containing that point a, except possibly at a. It doesn't have to be, because we're looking at limits. We're not looking at continuity like last time. We're looking at limits. We say that the limit of f of x as x approaches a is L, written as limit f of x as x approaches a equals L. If for any number epsilon greater than 0, there is a corresponding number delta greater than 0, such that absolute value of fx minus L is less than epsilon whenever absolute value of x minus a less than delta. As you can see, I'm repeating myself from the last graph, but if you look at this right here, it's actually distance. Absolute value, one way to define it is distance, alright, from 0. If you have an absolute value of x equals 5, the answer is 5 or negative 5. Why? Because if you plug in 5, absolute value of 5 is 5, and if you plug in negative 5 to test it, absolute value of negative 5 is also 5. What's interesting about absolute value is if you graph it on the number line and you graph the 0 and you graph the 5 and the negative 5, you will know that Yes, we are at two locations. With inequalities, any distance between that will cover it. Since this is calculus and it's not lower math, so I'm not going deeply into explaining the concept that this is a distance away from L. All the distances away from L within a radius of epsilon, that's what this one says. Let's move on, look at the graph. Here's the graph. So a smooth graph, as you could see right here, with this concept, what we are agreeing on. If you give me an epsilon, as was mentioned earlier, this is L, our limit, if A is targeting as an output L. That's what this says. Now going higher than L with an epsilon much, that's going to be L plus epsilon. Going down from L with an epsilon value, that's going to be L minus epsilon. So being between this point and this point, you're actually living a distance of epsilon from L. A distance of epsilon away from L. Alright? If you need help understanding that, just let me know. I'll explain it more. This right here, my center is A, my radius is delta, so I have an interval of a length of 2 delta. A delta to the right, a delta to the left, that's kind of like radius. That's what we call it. X minus A, a distance away from A, is less than delta. This point is far away from A, less than delta. This point is far away from A on the right side or higher by delta. Because you want it to be less, that should be open, that should be open. Everything here belongs to you and everything here belongs to you. Now, what this one says greater than 0, that means the distance is more than 0, so you can't pick A itself. We're looking at the limit, we're not looking at A itself to be involved. To explain this more about what I talked about distance and radius and epsilon, here's what I have for you. Absolute value of x minus L is less than epsilon. The distances of all f of x's right here from L will be less than that distance or radius, epsilon. Solving inequality with absolute value, we could translate that to two inequalities. We have f of x minus L less than epsilon and also greater than negative epsilon. Add L to all three sides to leave f of x alone, and now I could see that f of x actually lives between L plus epsilon and L minus epsilon. All f of x is here, they are less than L plus epsilon, and they are more than or greater than L minus epsilon. Let's look at an example in depth and in detail. Prove that the limit of 2x minus 3 as x approaches 5 equals 7. Well, if somebody says, you know, I could see it, it's so simple, I'm just gonna plug it in. Yeah, we could see that, but that's not a proof. We're trying to use a precise definition of limits with epsilon and delta, and that's why I have this example for you. Because it's a polynomial and there is no issue, there is no fractions, there is no denominator with zeros, I could just plug it in. X approaches 5 will be like 2 times 5 minus 3, 10 minus 3, which is 7. Yeah, that is true. When somebody says prove to me, that means they're giving you the answer, but you just have to show it. So we do believe that the limit is 7. Yeah, we do. Now here's my notes step by step. And as you could see, because it's one example, I'm reading it slowly. And you could always, as I mentioned earlier in previous videos, always when you see something and you want me to go forward so you could look at the screen, Just hit the space bar on your keyboard. It doesn't matter if it's Mac or PC. That will stop it. And hit the space bar again. That will make it play. It's like you have your own remote control. So for every epsilon greater than 0, there is a delta greater than 0 such that f of x minus L absolute value is less than epsilon whenever absolute value of x minus a is less than delta greater than 0. As you could see, I keep repeating myself, so I don't want to do this many times. I'm doing it for one example so you could be able to practice more, and if you need more examples, just let me know. That is, for every epsilon greater than 0, there is a delta greater than 0 such that instead of writing f of x minus L, I wrote f of x minus 7, because we should agree that this is L, 7 is L, and 5 is A. So instead of A right here, I'm writing 5, step by step. Next step, I'm gonna go after f of x right here and write 2x minus 3. Same thing, except as I mentioned, instead of writing f of x, I wrote 2x minus 3. Simplify the algebra right here, and we should be fine after. So what's the whole idea here? The idea is that we are given epsilon, and we need to find the corresponding delta that works between this piece and this piece. But let's look at this right here on a separate page. Keep that in mind. We'll come back to this. Of course, you're gonna have to memorize it for now. I mean, while I'm going over this example, all what I'm doing is this and this, this and this, back and forth. I want to make a connection. So let's take 2x minus 3 minus 7, absolute value less than epsilon, to a new page. It's right here. Simplify inside, 2x minus 10, factor 2 out, and I have this. Well, let me take you back. Do you see x minus 5? That's part of the game. It's right there. X minus 5. Most of the time that's what happens. If you don't see that, that's why you need more skills to play the game. I call it play the game. I call it skills. The more that you know, that should help. So get rid of the 2 so you could focus on the absolute value of x minus 5. We're trying to make a connection, by the way, if you notice. So now this absolute value of x minus 5 is less than epsilon over delta. But earlier I mentioned to you to look at this. Now look at absolute value of x minus 5. We want to find delta that works with this. But if you do the connection and make a connection between epsilon and delta, what do you think? It's happening. So if this one came to be less than epsilon over 2, which is half epsilon. So you give me epsilon, any epsilon that you give me. Just for example, if epsilon is 5, I mean, we don't pick epsilon is 5. Usually epsilon is like 0.001 and 0.0001. We're trying to make it so small to try to tell you that, yeah, I'm approaching this limit. So we're trying to be right there. But let's say it's 5. So if you give me epsilon is 5, I'm telling you that this simplifies to 5 over 2, which is 2.5. Which means I could just pick delta to be 2.5. Because that is, if that is 2.5, that's going to agree with you, which is 5 over 2. And that's going to end up the story. But this is just like talk, but let me write it down in steps for you. So we're going to let delta be epsilon over 2. If you give me epsilon, I'm going to divide by 2 and give it to you. Of course, I could divide by 100, and I'll guarantee that everything's going to work nicely, but we don't want to make it now complicated. So formally, if somebody says, I don't get it, I don't understand, how can I show this or present this, let's say on a whiteboard? Here's my steps. Let epsilon be greater than 0 and assume that absolute value of x minus 5 is less than delta. This should be greater than 0. That's my typo, sorry. Such that delta is epsilon over 2, half of epsilon that you gave me. The idea is to show that f of x minus L, I'm reading it with a concept, will be less than epsilon for all x such that absolute value of x minus 5 is greater than 0. See, I didn't forget it right here. Will be less than delta. I'm using 3 different colors right here to make the connection. Now, absolute value of f of x minus L, we know f of x and we know what's our L, simplifies to inside 2x minus 10. Factor the 2 out. We just did that earlier and we know what we're doing. Now the 2 out, this absolute value of x minus 5 underlined with green, it's right here. But that is what's underlined in green is less than delta. So I'm gonna take that, multiply by 2, and say that's less than 2 times my delta. But delta is epsilon over 2. If I keep saying this over and over, I might confuse you. It's not confusing at all, trust me. Just look at it with the colors, compare. If I say this is less than this, that means twice this will be less than twice this. That's why the 2 shows up. So pretty much these are the same, except the 2 is on the left and the right, if you call it left and right. So, for every epsilon greater than 0, absolute value of f of x minus L, which equals, in our case, to absolute value of 2x minus 3 minus 7, will be less than epsilon for any epsilon that you give me. Whenever absolute value of x minus 5 is less than delta, provided that delta is less than or equal to epsilon minus 2, so any number smaller than that will guarantee that the limit of 2x minus 3 as x approaches 5 will be 7. And that should do it. Okay? I know one example is not enough, so I think I did my part for now, and we'll continue for other videos to move on with Calculus 1. And if you have any comments or questions, just let me know below and I'll take care of it. And once again, thank you for watching, and we'll see you on the next one. Thank you. Thank you for watching. Subscribe and hit the like button if you did like this video. If you have any comments or questions, leave them down below and I will get back to you. And I'll see you next time.